Welcome to the Chemistry, Biology and Math Revision Hub. Today we're doing the Pearson Edexcel International GCSE Chemistry Paper 2C for June 2024. Let's begin with the first question. In question 1, use the periodic table to answer these questions. Part A says give the name of the element with atomic number 16. This should be sulfur. And then give the name of the element with relative atomic mass 9. If you look at the periodic table, this is going to be beryllium. And then give the name of the element in group 3 and period 2 of the periodic table. This is going to be boron. And give the electronic configuration of silicon. Silicon has 14 electrons. It's in group 4, so 2, 8, 4. In part B, explain in terms of electron configuration why sodium is more reactive than lithium. Sodium has 3 shells while lithium has 2 shells. So the outer electrons that are going to react in sodium are farther away from the nucleus, so they're easily lost. So I said sodium has the electron configuration 281 and lithium has 21. The outer electron in sodium is farther from the nucleus than in lithium, so it's less strongly attracted. This makes it easier for sodium to lose its outer electron, making it more reactive. In question 2, structures made of iron can rust. Name the 2 substances that cause iron to rust. This is water and oxygen. Then state a barrier method that prevents rusting. This could be painting, greasing, coating with plastic, and so many more. In part B, explain how sacrificial protection prevents the rusting of iron. This works by coating the iron with a more reactive metal. This metal will form an oxide, and the oxide makes a coating on the surface. So I said in a sacrificial protection, a more reactive metal, for example zinc, is attached to the iron. The more reactive metal corrodes, oxidizes, instead of the iron, protecting it from rusting. Then question 3, the diagram shows the separation of crude oil into fractions. We can see the different fractions. They say give the name of fraction A and the name of fraction F. This is refinery gases, about carbon 1 to carbon 4, and this is bitumen. Then they say one of the fractions is kerosene. Give one use of kerosene. It's used as fuel in aircrafts. Describe how kerosene can be obtained from crude oil. If you can see back here, kerosene is one of the fractions. So it means we're going to heat the crude oil. It's going to evaporate and rise into the column. And then the different components are collected at different temperatures or different levels. So kerosene will be collected here. So I said crude oil is heated and its vapors rise in the column. Kerosene condenses at its specific boiling point range in the middle of the column. In part C, catalytic cracking is a process used to break down fractions containing long chain molecules. Give the name of the catalyst and the temperature used for catalytic cracking. The catalyst, alumina or silica. The temperature range about 600 to 700 degrees, but you could do about 650 degrees within this range. Explain why catalytic cracking is useful. It's useful because it helps to break down the long chain alkanes into smaller chain ones or shorter ones, as well as producing alkenes, because the smaller ones have more uses. So I said it breaks down large, less useful hydrocarbons into small, more useful ones, produces alkenes which can be used in making plastics, and it increases the supply of fuels like petrol that are high in demand. In question 4, the table shows the maximum mass of potassium nitrate and the maximum mass of sodium nitrate that dissolves in 25 centimeters cubed of water at different temperatures. So they've given us the results here. The first part says plot the data for potassium nitrate and for sodium nitrate on the grid. So the data we're going to plot is potassium nitrate that and sodium nitrate that, of course temperature being on the x-axis. So they've already labeled the axis for us. And I plotted the points that corresponding to the scales that were given on the x-axis. And then the next part they said draw and label a curve of best fit through potassium nitrate and sodium nitrate. In this case, because I was working with an iPad, my curves are not that smooth, but I tried my best. So this is for potassium nitrate and that is for sodium nitrate. The graph shows the temperature at which the maximum mass dissolved is the same for each solute. Determine this temperature. We need to go back to the graph. Both of them, this is going to be the temperature, which is about 68 degrees. So that was my answer here. Then use your graph to calculate the solubility in gram per 100 grams of water of sodium nitrate at 30 degrees Celsius. So we go back here at 30 degrees Celsius. This is 30. The mass is 24 grams. So these 24 grams are in 25 of solution. Since the density and the volume are equal, I can say 24 grams of the potassium nitrate in 25 grams of water. And so solubility will be 24 divided by 25 times 100, giving me 96 grams. This is like scaling up. If this is in 25, then in 100 we'll have 96 grams as the answer. Then in part D, 25 centimeters cubed of a saturated solution of potassium nitrate is cooled from 50 degrees Celsius to 20. Use your graph to determine the mass in grams of potassium nitrate that crystallizes. Show your working. So we go back to the graph, do 50 and then 20. So at 50, we have that. The mass I saw was 21, and at 20, the mass was 8. Meaning, when you're cooling, the amount of solid that is going to crystallize is going to be 21 minus 8. So 21 minus 8 is going to be 13 grams as the answer here. In question 5, methanol is the first member of the homologous series of alcohols. Give 2 characteristics of a homologous series. I wrote all the 5. They have the same general formula. They have a gradation in physical properties. They have similar chemical properties. Members that follow each other in the series differ by a CH2 group, and they have the same functional group. Then in part B, methanol is heated with potassium dichromate and one other reagent. The methanol is oxidized to methanoic acid. Give the formula of the other reagent. Sorry for that, they said formula, so I'm going to write it like that. It's sulfuric acid. So I've changed that. They wanted the formula, not the name. Then they say give the color change that occurs during the reaction. This is the oxidation reaction, so the color change is going to be orange to green. And then draw the displayed formula for methanol and for methanoic acid in the boxes. Methanol, it has CH3 or H. If I want, I can display this as well. And then methanoic acid is going to be like that. I've displayed this bond as well. Then they say methanol reacts with methanoic acid to form an ester. Complete the equation for the reaction. So because this is methanoic acid and this is methanol, the ester is going to be methyl methanoate and then water. Then part D, the structural formula of the ester, which is that. What is the name of this ester? Now, if you look at this ester, this part, the CH3CO comes from the carboxylic acid, and this CH3CH2CH2CH2O comes from the alcohol. So since it's a butanol, so it's going to be butyl and then ethanoate. So the answer should be butyl ethanoate, which is A. Then deduce the molecular formula of this ester. It's carbon 6, hydrogen 12, oxygen 2. That's the answer. In question 6, the scientist reacts lead to nitrate solution with sodium bromide solution. This is the equation for the reaction. Then describe how the scientist could obtain pure dry sample of lead to bromide from the reaction mixture. Since the reaction has already taken place, we just take out these crystals, filter them, and since they're insoluble, we can wash them with deionized water, and after we could find a suitable way of drying them gently. So I said mix the solutions. Of course, this is irrelevant because it's just already the reaction is done, but if not, you mix the solutions, lead to nitrate and sodium bromide until the precipitate forms. Then filter the mixture to separate the solid from the solution. Wash the precipitates with distilled water to remove impurities and leave the solid to dry in a warm place, or you could use a warm oven or a desiccator. In part B, the scientist reacts an excess of lead to nitrate solution with 25 centimeters cubed of sodium bromide solution of concentration 2 mol per decimeter cubed. Show that the amount of sodium bromide used is that. Here we need to find the number of moles, which is the concentration times volume. We have the concentration and the volume, but this volume was converted to decimeters cubed. So multiplying the two, I got 0.05 mole. Then show that the maximum theoretical mass of lead to bromide is approximately 9 grams. From the equation, we saw that 2 moles of sodium bromide give 1 mole of lead bromide. So moles of light bromide are going to be half moles of sodium bromide, which is going to be 0.025, and so the mass will be number of moles times the molar mass, giving us that times this molar mass here, and I got 9.175 grams, which is approximately 9 grams. Part C, the scientist electrolyzes molten lithium bromide using this apparatus. We can see the positive electrode, the negative electrode, and the electrolyte. This is not a solution, it's just molten lithium bromide. This explains why lithium bromide needs to be molten rather than solid for electrolysis. This is an ionic compound, and there are no free electrons or free ions, yet to conduct electricity we need at least either free electrons or free ions. So melting it allows the ions to be free so that electricity can be conducted. So I said in solid form, ions are fixed in the lattice and cannot move. In molten form, ions are free to move, allowing them to carry charge and complete the circuit. Electrolysis requires mobile ions to conduct electricity. And the electrolyte is at a temperature of 400 degrees Celsius. Explain a suitable material for the electrodes. This should be something that has a very high melting temperature and does not easily react. So I said graphite is suitable because it has a high melting point and will not react with the components during electrolysis. They say give the half equation that occurs at the negative electrode. At the negative electrode, the cation in solution is going to come and receive 2 electrons to become lead. Then in part D, bromine forms at the positive electrode. This is the half equation for the reaction at the positive electrode. State what is observed at this electrode. This is bromine, and you know these temperatures are going to be higher, so it's going to be a gas, a brown gas or vapor is going to be formed. Then state why the half equation represents an oxidation reaction. Oxidation is loss of electrons, so since electrons are lost, we can say bromide is being oxidized to bromine. In question 7, this question is about hydrogen chloride. Hydrogen chloride is a covalent compound. State in terms of electrostatic attraction what is meant by a covalent bond. A covalent bond is the electrostatic force of attraction between a shared pair of electrons and the nuclei that are bonded together. Part B, when hydrogen chloride gas is dissolved in an organic solvent, the hydrogen chloride remains a covalent molecule. When hydrogen chloride gas is dissolved in water, ions are formed. Explain what happens when dry blue litmus paper is dipped into separate samples of each solution. So in water, because there is going to be ionization, it means that H+ ions are going to be free, and then the litmus paper, if it was blue litmus paper, it's going to become red, and then there will be no observable change in the organic solvent since the hydrogen ions will not be free. So I said in an organic solvent, HCl does not ionize, so it stays as molecules, and so the blue litmus paper stays blue. In water, HCl ionizes, the H+ and Cl- are released, H+ ions make the solution acidic, so the blue litmus turns red. In part C, in the presence of UV radiation, hydrogen reacts with chlorine to form hydrogen chloride, and the equation is shown here. They've given us the table of bond energies. They say calculate the enthalpy change in kilojoules per mole for the reaction. Include a sign in your answer. So here we have one hydrogen bond, one Cl bond, and the other side we have 2 HCl bonds. So the total bonds broken will be 1 times 436 plus 1 times 242, giving us that. And the bonds that are going to be formed are going to be 2 times this one, giving us that. Then the enthalpy change should be the total of the bonds broken minus the total of the bonds formed, giving us negative 184 kilojoules per mole. Then draw a reaction profile for the reaction. A reaction profile involves an activation energy line. So I position, because this reaction is exothermic, I position the reactants higher than the products, and then I showed the activation energy hump, then the delta H for the reaction, which is exothermic, and also label for the activation energy. Then I included this progress of reaction because for the reaction profile, we usually label the x-axis as well. So this brings us to the end of question 7, as well as to the end of the whole paper. Thank you for being with us. Do not forget to subscribe. See you in the next video. Bye-bye.